welcome to my first video on Leetcode. I want to mix it up a little bit in my channel and not just do data science and data analysis, machine learning, all that stuff. I want to do some Python programming as well with some problem solving questions in Leetcode and other sites. So this is Leetcode. If you make an account, you'll see it's something like this: explore problems, click on problems, and you have many problems with like a few thousand, I think, and you can choose algorithms, databases, all of the other stuff, and so on. Alright, so I picked up 3 questions for this video. In my Leetcode videos, I'm just going to do 3 questions. The first 2 are going to be fairly easy, similar questions, and the third one's going to be a bit harder. And yeah, this is what, once you click on the problem, this is what you're going to have. You have the description and solutions. You can look at other people's solutions and your own submissions. And if you look over here, you can choose your preferred programming language to do your code and solve this problem in. So there's C++, Java, Python, Python 3, and so on, many other ones. And obviously we're doing Python 3 for the type of work we're doing, like data analysis, data science. We're using Python. So this is the first question, 1295. And if you go down here before we start, it says accepted 557,000 and submissions were 723,000. So 557,000 were accepted of the 723,000 submitted, and the acceptance rate is 77%. This shows that this is a fairly easy problem. It's on the higher rate of acceptance, higher end, and sometimes this can be misleading. Problems with high acceptance don't always mean they're easier to solve. Sometimes it just means that certain amount of people just solved it, and it can be skewed. So for example, one person, if he makes a mistake, 100 mistakes on one question, 100 submissions, and they're all wrong, he's skewing the results, lowering the results. I've seen questions with 33% acceptance rate being a lot easier than the 70s and 80s. Well, yeah, let's start off with our first problem. 1295. It says find numbers with even number of digits. Alright. Given an array nums of integers, so our array is called nums, and it contains integers, return how many of them contain an even number of digits. So the integers, how many of those integers have even number of digits in them. Okay, so let's just look at the example to understand the problem a little bit better. So here's our array, nums, that's the array here. So nums equals 12, 3, 4, 5, 2, 6, 7, 8, 9, 6. Okay, and the output it gives us is 2. If we look at this, why is it 2? Just looking at the numbers, the problem is asking for even number of digits. How many of these integers have even number of digits? So 12, look at 12 first. 12 contains 2 digits, the 1 and the 2. So even number of digits. 2 is even. Anything that's divisible by 2 is even, and else is odd. So 3, 4, 5, there's 3 digits, that's odd. 2 is 1 digit, it's odd. 6 is 1 digit, it's odd. 7, 8, 9, 6 contains 4 digits, even number of digits. So it's a fairly simple problem. And it says therefore only 12 and 7, 8, 9, 6 contain an even number of digits. And if you quickly look at example 2, just by looking at it, you can see that only 1771 has 1, 2, 3, 4 digits, even number of digits, so the output is only 1. So in a sense, we're counting, we're getting an output. The output is the count of how many integers in a certain array has an even number of digits in them. It contains an even number of digits. So how do we start off with this problem? So since we're counting, we need to have a placeholder or like a counter that counts for you in your code, that you add 1 each time you spot an integer with even number of digits. So that's what the return is, how many of them contain an even number of digits. So we're returning a number, so we just need to return a number. So how I would do it is count equals 0. We start at 0, but you could write even number of digits equals 0. I wrote number wrong. Well, I don't know why you would do this, it's just a lot longer. So even number of digits, it starts at 0 and it counts it every time it spots another integer with even number of digits. So I'm just going to stick to count. My count equals 0. So this is what we're going to return, and we start off with count. So we're gonna this number is going to increase every time it spots an even number, and essentially the code is going to just loop through the array. It's going to go, check each number in the array, each integer, and let you know if it has a even number of digits, it's going to add 1 to the counter. That's what we're going to try to do. So we do a for loop. So for, I would usually write I in nums, for example, but I'm just going to write for num. So for num can be integers, or should I just write int? So integers, for integers in our array nums. And what are we looking to see? So we need an if statement. So we're looking for even number of digits. So if it's even or odd, those are what we're looking for. So we need an if statement that if it is even, it's gonna add 1 to the counter. It's gonna be like, okay, we spotted an even number, let's add 1 to the counter. So we start our if statement, and I'm gonna explain this later on after this question. But we have to, if we look at what we're doing, we're counting the digits. So this is 2 digits long, this is 3 digits long, this is 1 digit long, 1 digit long, and 4 digits long. So we're looking at the length of these numbers, for example. So there's a Python thing called len, working out the length of something, and we cannot use this in for integers. I'm going to explain that afterwards, but we have to convert it into a string first. So we want to work out the length of the integers. We have the numbers we have the length of it, but we have to turn it into a string first to work out how many digits there are. And I'll explain that integers. So if the length of the integers is even, so how do we work out if it's even? So if you've seen the modulo function, there's this percentage sign over here. It's the modulo function, and it basically works out the remainder. So quick example, if we have 10 modulo 3, the answer would be 1. So 3 goes into 10 3 times, so it would be 3, 6, 9, and there's 1 remaining. That's the 1, that's the remainder. So it works out the remainder. So to work out if a number is even, you have to know if it's divisible by 2. If it's divisible by 2, that means the remainder is going to be 0. So that's what we do here. So the length of the integers, if it is divisible by 2, so we do modulo 2. If it's divisible by 2, it means that there's going to be no remainder, so it equals 0. And then, so we've done the if statement. If this is the case, then you do something. Then the code has to do something. If that's the case, it does something. So what we do is, with an indented line here, inside of the if statement, we just write count plus equals 1. We increase the count by 1. This will be increasing it by 1. If we want to decrease it by 1, we just do minus equals. But we're increasing it by 1. So every time while it's looping through the array of nums, every time it spots an even number of digits for the integers, it's going to increase the count by 1. And at the end of it, however many even digits there are, it's going to be there. And since we're returning the count, all we have to write is return count. And that should be it. Let's see the result. And wrong answer. That's wrong because I put this return in the wrong way. I put it inside the loop. It should be outside. So you return count. Let's run it now. Yep, it's accepted. And go down here, submit. And once you submit something, you can see what other people have done, your previous submissions. As you can see, my first one was in May 4th for this question. And if you click over here, you can see other people's code. Someone done it in a complete different way to me. Someone done a list comprehension, and so on. There's different ways to do the same problem. Alright, that was the first question. And before I move on to the second question, let me just go onto a Google Colab notebook, and over here, new notebook. I'm going to go into a Google Colab notebook and explain the string. So let's just say we have nums equals 345. That's an integer. 345 is an integer, whole number. Let's just say print the length of nums. Let's see what it says. Just let it run for a bit because it's just started. Oh, object of type int has no len. Okay, let's add some more code cells. If we do it like the previous one, nums equals 345, and then print len string of nums. Let's see if this works. Yeah, 3. So length, there's 3 digits, 1, 2, 3. And then basically this is what it is when it's a string. This was what it will be. It will be written like this: 3, 4, 5. Now with a string you can work out the length. There's 1, 2, 3 digits here. It's 3 digits long. And then another. So if we just do print len of nums now, we turn nums into a string here already, so we do not need to write string there. If we just do print len nums, it's going to be 3. And another one, it can be nums equals an array, let's say 3, 4, 5, and the same as before, print len nums should be 3 as well, 3, 3, 3. So with integer you can't do that, you have to convert it into a string, and we can do more of this in the future. And yeah, so that was the first question done. Second question. This question is very similar to the first one, so I'm not going to, get into too much detail. I'm just going to do it, but it's good to do similar questions to just drill it into your head how to do the method. So it says 771 joules and stones. That's the question. Problem type or problem number. It says you're given strings joules representing the type of stones that are joules and stones representing the stones you have. Each character in stones is a type of stone you have. You want to know how many of the stones you have are also joules. Reading that is kind of stressful. Looks like I'm trying to decipher something. Letters are case sensitive. Okay, so they're case sensitive. That means this lowercase a is considered a different type of stone from uppercase A. Alright, so lowercase a is not the same as uppercase A. And in the example, we just look at it quickly. Input joules equals lowercase a, uppercase A, and stones is lowercase a, 2 uppercase A's, and 4 lowercase b's. And the output gives us 3, because if you look at joules, you have lowercase a appearing once in stones. That's 1, add 1 to the counter. And then uppercase A appearing twice in stones, so we add 2 to the counter there. So we have 3 in total. Let's look at example 2. Input joules equals z, lowercase z. Stones is 2 uppercase z's. So they're not the same, and they don't appear in each other, so output is going to be 0. Alright, so same as before, since we're counting, the output is a number, and we're counting how many there are of something in another thing. We just do count as before equals 0, and then we start it off with the same way. So a for loop. We're going to start off as a for loop, and then it's pretty much going to be exactly the same code with a minor difference. So this one I'm just going to use I for I in stones. For I in stones, so I can be these letters in stones, so all these letters in stones. And we have an if statement. If the I is also in joules, so if this for the I's, so for the letters in stones, if it's also in the joules, if those same letters are also in the joules, we're gonna add 1 to the counter, increase the counter by 1, count plus equals 1 as before, and then finally return count. Fairly simple, and it's basically the same type of question, just a minor difference. The other one was working out if it's an even number or not. This one you're working out if a certain letter in stones is also in joules. That's it. Let's run it, and it should be correct. Yep, there we go. Submit, and yeah, let's submit that. And finally, last question, 1342, number of steps to reduce a number to 0. Okay, so we're reducing a number to 0. We're starting off with a certain number, going down to 0. It says given an integer num, an integer, whole number, return the number of steps to reduce it to 0. So we're looking for how many steps it takes. We're counting the steps, so remember that. We're going to have another counter. Let me just put it there. So break this problem down into steps. So count equals 0. We have a counter. In one step, if the current number is even, so if the current number is even, you have to divide it by 2. So if the number is even, you divide by 2. Remember that. Otherwise, you have to subtract 1 from it. So it means if it's even, you divide by 2. If it's odd, you take away 1. So let's look at an example to understand this. Example 1, num equals 14. 14 is an even number. It's divisible by 2. So step 1, 14 is even, divide by 2. Okay, then you obtain 7 when you divide by 2. Now, this 7 is your new number you start with. So your new number you start with is 7. 7 is odd. Subtract 1 and obtain 6. 6. That's your new number to start with. 6 is even, divide by 2 and obtain 3. 3 is your new number to start with. 3 is odd, subtract 1, remainder 2, and so on. And finally, when you get to 1, 1 is odd, subtract 1, and you obtain 0. So our code is going to do something while our number is greater than 0. While our number is greater than 0, just write it here. While our number is greater than 0, we follow the steps or rules. We follow the rules. Alright, so that's the problem, and then we're counting. Alright, so example 2, quickly look at example 2. Is a number equals 8 and it outputs 4. Let's look. It took 4 steps, so 1, 2, 3, 4. 8 is even, divide by 2, you get 4. 4 is even, divide by 2, you get 2. 2 is even, divide by 2, you get 1. And 1 is odd, subtract 1. So this is a much easier one. Most of it is even until you get 1. And then another example, num equals 1, 2, 3. Output is 12. I'm going to explain that one. And so on. So how are we going to do this? Like I wrote here, while our number is greater than 0, we follow the rules. So that means as long as the number is greater than 0, we do certain steps, and that means we're going to be doing a while loop in Python. While. So if you haven't done while loops, it will help to just quickly look over it. So what I've written up here, I'm basically going to write it in a code format. So while num is our integer, remember, the number that we get. While num is greater than 0, now we do certain statements inside. So we're going to do if statements. If it is even, we do one step, a certain step. If it's odd, we do another step, follow another rule. So let's start off with the even one. If, and from the previous example, we know how to work out if a number is even. So if this number is divisible by 2, so if the remainder is 0 with the modulo 2, then we do, what do? You divide by 2, and then that's one step. So we divide by 2, so we do count plus equals 1. You add 1 to the counter because that's one step done. This is one step. And then what do you do to, wait, let me write it in a different way. Let me write the step first. So what do you do to it? You do num. So your new number, if we look here, it is even. You divide by 2 and you get 7. So if it's that, your new number equals num equals the old number divided by 2. Alright, so that's the even case. However, if it's odd, we do another thing. So we don't need another if statement, it's just else. Otherwise, that's it. It's just two things you're following. Else num. So in this case, pretend that there's an if statement saying if it is odd, then you do new number equals old number, take away 1. So just to explain this, if we're on 7, new number is 7. So 7, sorry, not new number, sorry, new number is 6. New number 6 equals the old number 7 from above here, 7, take away 1. Take away 1. That's what we're doing basically. See, writing it in this format. So num equals num minus 1. That's for the odd case. And then once we do this step, we add 1 to the counter as well. Count plus equals 1. Oh, I forgot to write that up here as well. Count plus equals 1. So in both these cases, when these are steps. This is a step, so we add 1 to the counter. We tell the code to do a step, and then add one to the counter, like here, step 1, step 2, step 3. You know, step 1, 14 is divided by 2. Step 2, 1 is taken away from 7. So that's what we're doing here. And finally, all we do now is return our counter to see how many steps it took. So return count. Let's see. Yep, it's all accepted, and we can submit that. Yeah, those first 3 questions were fairly easy. It's my first video, and I'll be doing more of this in the future with harder questions and different types of questions, hopefully increasing my own knowledge as well. But Leetcode is important for, you know, improving your problem solving skills as well as your programming skills. And yeah, it's good practice as well, and it's quite fun to do. And Google Colab or other places, you know, you can use VS Code, Google Colab, Jupyter Notebook, or whatever you want to use, PyCharm. I like to have them open on the side so I can, you know, write something and check if it's true. Like I'll do print and see what the output of my code would be, so I can do these. You can say this are the working notes, you know, the rough notes, before I, you know, submit it here. So Google Colab is one of the easier ones to use, and I hope you enjoyed the video, and I'll be back with more in the future.